Hello children of the universe and welcome back to my channel, Makeup and Science. My name is Darky and this is where I like to play with makeup whilst I talk to you about a science topic. And today's topic is on the atom. Now, before I get started, I'm just going to say that I will be leaving all products used in the description box below, and all the resources for the scientific information is also going to be linked in the box below. So, without further ado, I'm going to get started. So, the atom was first hypothesized by the ancient Greek philosopher Leucippus of Miletus, but it was his disciple Democritus of Abdera who finished the theory around the year 430 BC. Democritus wondered what would happen if you cut a piece of matter, like an apple, into smaller and smaller pieces. He hypothesized that it would reach a point where the matter could not be cut any further. He called these uncuttable pieces atomos, which is where our modern term for atom comes from.
Democritus believed that atoms were uniform, solid, hard, incompressible, and indestructible. Atomists theorized that these bodies, from which everything else is composed, moved about in an infinite void. Even Democritus's biggest critic, Aristotle, praised Democritus for arguing from sound consideration of the natural philosophy of the time.
The Greek atomic theory is very significant historically, but was based purely on philosophy and not science. The Greeks used mathematics and reason almost exclusively when writing about physics and not actual observations and measurements of the world around them. The emergence of experimental science helped pave the way to the modern understanding of the atom that we have now. So it starts with a poem written by a Roman philosopher, Lucretius, discussing atomism. The poem was rediscovered in the 15th century, so people started talking about atoms again, and then popularized in the 17th century by Gassendi. Now, this guy was a French priest, and he wanted to remove atomism from its worldly background, arguing that the Christian God created atoms. So, soon after Galileo expressed his belief that vacuums can exist, scientists began to study the properties of air and partial vacuums to test the relative merits of the atomic theory. You're probably wondering, what does air pressure and vacuums have to do with atoms? But it's through hundreds of years of gained knowledge that helps to prove the existence of the smallest particle in the known universe. In 1662, Boyle published the first physical law expressed in the form of an equation that describes the functional dependence of two variable quantities, becoming known as Boyle's law. Boyle's law played an important role in today's atomic theory, for it was soon after the development of his law that he hypothesized that all matter is composed of solid particles that combine together into molecules to give materials its different properties. 40 years later, Isaac Newton proposed a theory that was very similar to Democritus, Gassendi, and Boyle. I'll read to you an excerpt from his 1704 book called Optics.
All these things being considered, it seems probable to me that God in the beginning formed matter in solid, massy, hard, impenetrable, movable particles, of such sizes and figures, and with such other properties, and in such proportions to space, as most conduce to the end for which he formed them, and that these primitive particles, being solids, are incomparably harder than any porous bodies compounded of them, even so very hard as never to wear or break in pieces, no ordinary power being able to divide that God himself made on in the first creation.
So, pretty much what he's saying is that in the beginning, God created a particle that was super hard, and everything else comes from those super hard particles. And that these particles came in variable different sizes with different properties, and that accounts for all the different matter that we have in the world. He was also saying how these particles made by God in creation were super hard and durable, that they could never ever break, nor could anyone ever enter them or change them in any form or way. So in some ways, true, other ways, not so true, but we'll get there. In the 18th century, Proust of France published his law of definite proportions, Proust's law, which states that the components of chemical compounds always combined in the same proportions. For example, copper carbonate is always 5 parts copper, 4 parts oxygen, and 1 part carbon. From these early stages of experimentations and observations, the modern theory of atomic theory was conceptualized. So, English chemist and physicist John Dalton extended Proust's work and converted the atomic philosophy from the ancient Greeks into a scientific theory. Dalton's atomic theory remains as one of the cornerstones of atomic chemistry and physics to this day. The theory is summarized in these 5 points. 1. Elements consist of particles called atoms. 2. Atoms of a specific element are all the same.
3.
Atoms of different elements can be told apart by their difference in weight. 4. Atoms of elements unite to form chemical compounds. 5. Atoms can neither be created or destroyed in a chemical reaction, only their grouping changes. By the end of the 19th century, scientists began to theorize that the atom may be comprised of more than one fundamental unit. In 1897, physicist J.J. Thomson announced that he had discovered a unit that was 1,000 times smaller and 1,800 times lighter than the hydrogen atom. Hydrogen is the smallest and lightest atom. He also discovered this particle held an electrical charge when it ran through metal and gave atoms their negative charge. The particle, once called a corpuscle, was later changed to electron. Sorry, I had the cat on me, so I was like slumping down so the cat could sit in my lap. I'm back up again. Through experiments carried out by Rutherford, Geiger, and Marden in 1909, Rutherford proposed that the positive charge that balanced out the negative charge of the electron was concentrated in the tiny nucleus within the center of the atom. In 1913, physicist Niels Bohr proposed electrons orbited this nucleus in sets of rings, also suggesting that the electrons could jump between the rings. This gave rise to the concept of quantum physics. With the development of the mass spectrometer, which uses magnets to bend the direction that ions travel in, this allowed chemist Francis William Aston to show that isotopes had different masses. In 1932, physicist James Chadwick proposed the existence of neutrons, which are neutral in charge, existed to account for the different weights in atoms of the same element. So from all of this, you get the basic structure of the atom. This image is Bohr's atomic model of the atom nitrogen, which has the atomic number of 7 because it has 7 protons. It is also demonstrating an unstable electron configuration. So the charge is neutral because you have 7 protons and 7 electrons, but in the second ring, it can only hold 8 electrons. The first ring that surrounds the nucleus can hold a maximum of 2, and the second 8. So if it's not at 8, if it's above 4, it will gain electrons by connecting with another atom, or if it's below 4, it will lose electrons by attaching to another atom, just so it can stabilize that outer shell. And the cat has returned. The nucleus in the center of the atom holds protons, which are positively charged, and neutrons, which have no charge. They weigh roughly the same, but neutrons are a little bit larger and heavier. Electrons are much smaller and lighter and live inside the electron cloud, which orbits around the exterior of the nucleus. For more in-depth knowledge about the orbits and shells of the electron cloud, you can look at the link I've left in the description box below. Now I will touch lightly on the subatomic particles to finish this video. The proton, neutron, and electron are subatomic particles, called fermions. They are a class of particle that is associated with matter, that is either elementary, the electron, or composite, the protons and neutrons. The electrons have no known internal structures, but the protons and neutrons can be broken down further. So technically, the atom is not the smallest particle in existence, but it is the smallest before you break it down and it releases any electrical charged particles. The other subatomic particles include leptons, quarks, forces, and the Higgs boson. And because today's video is not on subatomic particles, I will leave you this pretty picture. And please go to the link in the description box below for more information on subatomic particles in physics. Okay, so this is the makeup look done, but for the sake of science and also inspiration from the Watchman Dr. Manhattan, I am going to do a little something extra. Fun fact time. This design I'm drawing on my forehead nowhere near represents the true scale of the atom. The nucleus of the atom is tiny. The nucleus itself, in comparison to the atom, is 100,000 times smaller than the entire width of the atom. Which also means that most of the atom is empty space. That's right, children, we're not actually ever touching. We are literally held together by forces and the vacuum of space. So let's put this into a larger scale so you can understand the magnitude of the difference in sizes. Make the nucleus the size of about a tennis ball, so let's say 6.5 centimeters wide. That would make the electron cloud, so the entire size of the atom, 6.5 kilometers wide. That, children, is double the width of my suburb. And I know this because I go for a walk and it takes, 3 kilometers to get to one end and then it's like 3 kilometers to get back. Yeah. Massive difference. So the atom I've chosen to use today is the carbon atom, because it is the building block of all life as we know it. This is the origin of organic chemistry. So I would love to do another video on organic chemistry so I can explain to you what it really means, which is pretty much a carbon chain, and then there's other elements attached to it, which eventually build into everything we know as living. And that's today's science tutorial on the atom complete. I have left obviously all the information on makeup and science in the description box below. If you enjoyed watching this, please press the like button and consider subscribing if that is your thing. I'm also happy for you to write any comments or questions, or just to discuss this topic. I hope you did find it interesting and maybe a little bit educational. Excuse me for my kitty cat who is dying for some affection. Okay, so please tune in next time on Darky Doom's Makeup and Science. Bye!